Hi, I'm Dr. Kenberry, and today we're going to tackle something most people on the carnivore diet never talk about openly, yet it's the very thing that keeps doubtful beginners awake at night. You've probably heard people say that without plants, without traditional sources of fiber, without all the greens and whole grains that we've been conditioned to believe are required, your gut bacteria will starve, your digestion will collapse, and your entire microbiome will wither away. That fear leads to confusion, hesitation, and endless questions about what's actually happening inside the body when you remove fiber from plants and rely fully on animal foods. The problem is that most people are still trying to apply the plant-based digestive model to a biologically inappropriate human diet, and when they do, nothing makes sense. They think the gut bacteria behave exactly the same way under a carnivore diet as they do under a plant-heavy diet, and that misunderstanding produces myths, misinformation, and fear. So the solution is simple. We need to unpack the controversial questions hidden inside the carnivore diet. The questions people whisper about but rarely address with logic, physiology, and real-world evidence. By the time you finish listening to this, you'll understand not only what feeds your gut bacteria on a meat-based diet, but also why the entire conversation about fiber has been misunderstood for decades. When people first switch to carnivore, they panic because their digestion shifts. They assume something is going wrong because they've been taught to associate bulk and volume with health. But the human body is not a compost bin. It doesn't need unusable fiber to be healthy. One of the first controversial questions people ask is whether their microbiome will be destroyed without fiber from plants. This comes from the idea that bacteria only survive on fermentable plant polysaccharides. But the truth is far more interesting. When you eat meat, the gut bacteria adapt to a completely different food source, one that our species consumed for hundreds of thousands of years before agriculture existed. The bacteria shift from fermenting plant fiber to fermenting leftover proteins, collagen fragments, connective tissue, and especially the amino acids and compounds that make their way into the colon undigested. This is not a failure of digestion. This is a design feature. Your gut bacteria thrive on what your body doesn't fully break down, and meat leaves behind small amounts of material that the right bacteria use as fuel. The next controversial question is whether the lack of fiber from plants will harm bowel movements. For people who've been conditioned to measure digestive success by the size and speed of their stool, this can feel unsettling. But the reason stools get smaller on carnivore is because you're absorbing more and wasting less. Fiber bulks up waste because it's literally indigestible. Your body cannot break it down. So when you stop filling the gut with non-digestible material, the volume of waste naturally decreases. That's not constipation, that's efficiency. The smooth transition here is understanding that the carnivore diet doesn't stop your bacteria from functioning. It changes what they function on. Meat provides amino acids and fats that are far easier for the body to absorb, but the small amounts that do reach the colon become the perfect substrate for the microbial species designed to thrive in a low-fiber environment. These bacteria aren't the same ones that thrive in a plant-based digestive system, and that's where the shift becomes fascinating. Another controversial question people hesitate to ask is whether feeding gut bacteria meat-based residues creates harmful byproducts. They fear terms like putrefaction or ammonia production without understanding that the gut environment changes dramatically when carbohydrate intake drops. In the absence of fermentable carbohydrates, the pH shifts, the bacterial species shift, and the metabolic pathways shift. The environment becomes less hospitable to problematic bacteria and more supportive of beneficial species that thrive on protein fragments and mucin. Your body even increases the production of mucin, a natural internal fiber-like substrate that bacteria feed on. People panic thinking meat will rot inside them, but meat doesn't rot in the human digestive system. It is broken down with precision, beginning in the stomach where acid dissolves proteins and kills harmful microbes. Meat leaves very little behind, and what remains becomes fuel for the right bacteria in the right environment. The smooth progression here brings us to something almost no one discusses: how your own body creates its own internal fiber through sloughed epithelial cells, mucin secretions, and glycoproteins. These compounds act exactly like fiber inside the gut, feeding bacteria without requiring a single plant. This is why carnivores do not lose microbiome diversity the way plant-based advocates assume. The system is self-sustaining. The bacteria feed on what the body produces naturally. And that's something ancestral humans relied on long before kale salads existed. When you understand that, you stop worrying about the absence of plant fiber and start appreciating the body's built-in mechanisms that support digestive health. As we move forward, we need to dig deeper into the next controversial question, the one that creates the most hysteria online, and that's the belief that long-term carnivore eating destroys the microbiome. But the reality is far different, and in the next segment, we'll isolate that fear, break it apart piece by piece, and reveal exactly what the science actually shows about what happens to gut bacteria on a meat-based diet. Now that we've laid the groundwork and cleared up the confusion around fiber, we can move straight into one of the biggest controversial concerns people whisper about, but rarely address with honesty: whether a long-term carnivore diet destroys the microbiome. This fear usually comes from people who don't understand the basic shifts that happen when carbohydrate intake drops, and even more importantly, what happens to the gut environment when plants are removed. They assume a plant-filled microbiome is the gold standard, that more species automatically means better health, and that the presence of plant-fermenting bacteria defines a healthy digestive system. But the truth is that diversity in itself means nothing if the microbes you are hosting are built for a diet your ancestors never ate consistently. When someone switches to carnivore, the microbiome doesn't die, it reorganizes. It stops feeding bacteria designed for fermenting resistant starch and begins supporting bacteria designed to survive and thrive on proteins, fats, mucin, amino acids, and the internal substrates your body naturally produces. This is where people often get emotionally charged. They believe that fewer species equal worse health because they've been told more is always better. But imagine a mechanic who tries to repair every type of vehicle in the world versus a mechanic who specializes in the exact engine you drive. The general mechanic may know a little about everything, but the specialist knows exactly what your system needs. The carnivore microbiome becomes a specialist microbiome. It becomes efficient, lean, and focused instead of cluttered with bacteria that only thrive when fed constant plant fibers. When someone sees that their microbiome diversity decreases on a carnivore diet, what's actually happening is the removal of unnecessary bacteria that were only present because they were constantly fed foods humans never needed in the first place. The microbiome becomes streamlined, not damaged, and the bacteria that survive become incredibly efficient at extracting every usable nutrient from animal foods. One of the most controversial parts of this discussion is the claim that eliminating certain species of bacteria is dangerous. But the presence of bacteria that ferment plants does not automatically mean they're beneficial. Some of the species that disappear on carnivore are the same ones associated with bloating, gas, inflammation, and IBS symptoms in people who struggle with digestion. When plant foods are removed, those species lose their fuel and die off, leaving behind microbial communities that thrive without carbohydrate fermentation. This is not harm, this is adaptation. It's the same process your body uses when you switch from burning sugar to burning fat. The microbiome, like every other system in the body, responds to the fuel source it's given. A carnivore diet doesn't starve the microbiome, it transforms it into something that mirrors the physiology of ancestral eating patterns. And that shift often results in people having less bloating, less digestive discomfort, and more consistency in bowel function. Another controversial question that surfaces constantly is whether a carnivore microbiome produces harmful metabolites from protein. This fear is rooted in research that examine protein fermentation in individuals eating high protein but also high carbohydrate diets. When you mix protein with carbs, especially fermentable plant material, certain bacteria produce metabolites that aren't ideal. But when carbs are removed, the gut environment changes so dramatically that those same bacteria cannot survive, and the pathways that produce harmful byproducts become inactive. Instead, new pathways activate, and beneficial compounds like short-chain fatty acids are produced through alternative mechanisms. including the fermentation of mucin and specific amino acids. People assume SCFAs only come from plant fiber, but the human body is far more adaptable. On carnivore, SCFAs still exist, just produced by different means. The gut transitions into a low-fiber, low-carbohydrate ecosystem where bacterial species that thrive on amino acid residues become dominant, and they generate compounds that maintain colonocyte health and integrity. The smooth transition here brings us to another misunderstood area. People worry that without plant fiber, the gut lining will deteriorate because they believe fiber is required to maintain mucus production. But the opposite is true. When you eliminate irritating plant compounds like lectins, oxalates, phytates, and insoluble fibers that scrape and inflame the gut lining, your body reduces the constant need to defend itself. It no longer has to produce excessive mucus as a protective barrier. Instead, it stabilizes mucus production and maintains it with fewer stressors. The bacteria that consume mucin are not harmful when they exist in the right balance. On a carnivore diet, that balance is naturally regulated by the foods being consumed. Meat does not provoke inflammation in the gut lining. Plant toxins do. And when those toxins are removed, the gut lining often improves, the mucus layer becomes more stable, and the microbiome adapts to a calmer, less irritated environment. As the microbiome stabilizes into a carnivore-adapted ecosystem, another controversial question arises whether humans evolved to rely on plant-based fibers for digestion or whether that belief is a modern invention. And this is where the next segment becomes crucial because it takes us directly into the evidence of ancestral eating patterns, biological design, and the digestive physiology that suggests fiber dependency is far more cultural than scientific. The next segment goes deeper into why humans are not built like herbivores, why our microbiome is fundamentally different from fiber-dependent species, and how meat-based diets shaped our evolution long before modern nutrition guidelines existed. As we move forward from the confusion surrounding the microbiome and the emotional arguments wrapped around fiber, we enter the next major controversial question that people hesitate to confront: whether the human digestive system was ever designed to rely on plant fiber in the first place. This question makes many uncomfortable because it challenges the nutritional beliefs they grew up with. We've been taught since childhood that vegetables clean the gut, fiber keeps things moving, and humans need plant roughage the way herbivores do. But when you examine human physiology, human evolutionary biology, and the developmental changes that occurred over hundreds of thousands of years, you start to see a very different story unfold. The truth is that humans are not equipped with the fermentation chambers that herbivores rely on to extract nutrients from fiber. We do not have the multi-stomach design of cows, the expansive hindgut of gorillas, or the capacity to break down cellulose the way true herbivores can. Instead, we possess a digestive system built for nutrient density and efficiency, one that prioritizes high-value energy sources and minimizes waste, which is exactly what a meat-based diet offers. This leads to the unsettling question many people wrestle with: if humans aren't built like herbivores, why were we told fiber was essential? The answer is found in the agricultural shift that drastically changed human diets. Once grains and plant-based staples became primary food sources, digestive discomfort skyrocketed. People became bloated, constipated, and inflamed from eating foods that required significant mechanical and microbial breakdown. Instead of questioning the suitability of the foods themselves, society doubled down and insisted that adding fiber would fix the very problems those foods created. It was never about fiber being necessary for human biology. It was about compensating for foods the human body wasn't designed to rely on. When people today remove those foods and return to a carnivore diet, the digestive system suddenly operates the way it was meant to, and the need for fiber disappears. The gut no longer has to push through indigestible plant matter, block irritants, or fight off chemical compounds that challenge the intestinal lining. It becomes a clean, calm environment that thrives on bioavailable nutrients with minimal residue. Another controversial question emerges here, and that's whether removing plant foods eliminates important phytonutrients. This concern comes from a misunderstanding of what phytonutrients actually are. People assume these compounds are required for human health, But phytonutrients are defensive chemicals produced by plants to protect themselves from insects, animals, and environmental stress. They are not essential nutrients the way vitamins, minerals, amino acids, and fatty acids are. Humans do not suffer phytonutrient deficiencies because such deficiencies do not exist. In fact, many phytonutrients act as mild toxins that stimulate stress responses in the body. Some people tolerate them well, others react strongly, and others only look healthy on paper because their body is constantly in a state of low-level stress attempting to handle these compounds. When someone shifts to carnivore and removes these plant defense chemicals, the body experiences a reduction in inflammation, improved metabolic stability, and a calmer gut environment to smooth progression. Here leads to another deeply controversial idea that meat alone provides all the essential nutrients humans need without requiring supplementation. This challenges every modern dietary guideline, every nutrition class, and every mainstream message taught for decades. But when you examine the nutrient profile of animal foods, you see something extraordinary. Meat, eggs, and organs provide complete proteins, essential fatty acids, bioavailable vitamins, and minerals in forms the body absorbs far more efficiently than those found in plants. Vitamin A, vitamin K2, heme iron, B12, creatine, carnitine, taurine, DHA, EPA, and numerous cofactors necessary for brain and metabolic function are either missing entirely from plants or exist in forms the human body cannot efficiently convert. The human body evolved consuming these nutrients directly from animals, the same way our ancestors did while developing larger brains and higher metabolic capacities. These nutrient-dense animal foods supported the growth and intelligence that made humans uniquely capable among mammals. This brings us to another hidden question. People often feel afraid to ask, if meat is so nutrient-dense and humans are biologically designed to thrive on it, why do so many people believe plants are the foundation of health? The answer is that modern nutritional science often confuses correlation with causation. People who eat a lot of vegetables also tend to exercise more, smoke less, avoid processed foods, and care more about their overall health. The benefits attributed to plants are often the result of those healthy lifestyle patterns, not the plant compounds themselves. Meanwhile, people who eat a lot of meat in modern studies also tend to consume processed foods, sugar, seed oils, and refined carbohydrates. When researchers group all of this together under the label of meat consumption, the conclusions become skewed. This misunderstanding leads to false assumptions about meat being harmful and plants being inherently protective. Once you strip away these cultural beliefs and examine human physiology directly, the picture becomes much clearer. The digestive tract, stomach acidity, enzyme profile, colon size, intestinal length, and absorption pattern of humans all align with the species that evolved to thrive on animal foods first. Plants were survival foods, fillers, seasonal additions, or famine fallback options. They were never the foundation of human health. And this brings us to perhaps the most controversial topic of all, the part that sparks heated debates and endless online arguments, the belief that eating only meat is extreme, when in reality, it may be the most biologically appropriate diet humans ever followed. In the next segment, we're going to step into these final controversial questions head on, unraveling the fears surrounding long-term carnivore diets, addressing misconceptions about heart health and nutrient deficiencies, and exploring how gut bacteria adapt over years, not just weeks, on a meat-based lifestyle. Now that we've uncovered the evolutionary design of the human digestive system and dismantled the myth of fiber necessity, we can step directly into the final set of controversial questions that people hesitate to bring up because they fear they will sound uninformed, extreme, or reckless for even asking them. The first major concern that sits at the center of many debates is whether long-term carnivore eating is dangerous for heart health. People carry a deep-rooted fear of saturated fat and dietary cholesterol, a fear installed by decades of flawed research and repeated so frequently that it feels like unquestionable truth. But when you look at the controlled trials, the metabolic data, and the lived experience of thousands following a meat-based diet, a much clearer pattern emerges. Cholesterol does not cause heart disease, inflammation, insulin resistance, glycation, and oxidative damage do. A carnivore diet removes the primary drivers of inflammation by eliminating sugar, seed oils, ultra-processed carbohydrates, and gut-irritating plant anti-nutrients. What remains is nutrient-dense food that stabilizes blood sugar, lowers insulin, reduces inflammatory markers, and supports mitochondrial function. When the body is no longer fighting chronic inflammation, cholesterol becomes a tool for repair rather than a threat to fear. This leads us to another controversial question. If saturated fat and cholesterol are not the problem, why do lipid panels sometimes change when people start carnivore? The answer is that lipid panels were designed for a carb-based population. When carbohydrates drop, the body shifts fuel systems. LDL particles become larger and more buoyant, triglycerides fall, HDL rises, and the body begins transporting fat efficiently rather than storing it. But many people panic when they see an increase in total cholesterol without understanding that the type, size, and function of cholesterol particles matter far more than the total number. A rise in cholesterol on a low-carb or carnivore diet often indicates the body is burning fat effectively, healing tissue, and improving metabolic flexibility. This is why people on carnivore often see improvements in blood pressure, inflammatory markers, insulin sensitivity, and energy levels, even if their cholesterol numbers look different from what the old guidelines consider normal. The deeper truth is that normal cholesterol ranges were created based on populations eating diets that kept them inflamed, sick, and insulin resistant. So comparing carnivore-based lipid profiles to those ranges can be misleading. Another controversial topic that people quietly worry about is nutrient deficiencies. They ask whether they will miss out on vitamin C, calcium, magnesium, or other micronutrients if they eliminate plants. But when you understand nutrient form and bioavailability, you realize that animal foods provide highly absorbable nutrients in a format the body is evolutionarily adapted to use. Vitamin C needs fall dramatically when you remove sugar and inflammation because vitamin C competes with glucose for uptake. Meat provides small but highly usable amounts, and when the metabolic system is not overwhelmed with carbohydrate-driven oxidative stress, those amounts are more than sufficient. Calcium is abundant in sardines, salmon, dairy for those who tolerate it, and even bone broth. Magnesium appears in meat, seafood, and organs. The belief that plants provide superior nutrients collapses once you recognize that many plant nutrients exist in their precursor forms, require conversion steps, or are bound up in antinutrients like oxalates and phytates that reduce absorption. In contrast, animal foods deliver nutrients preformed, bioavailable, and accompanied by the cofactors required for proper assimilation. The smooth flow into the next concern brings us to one of the most emotional questions: whether the gut bacteria will wither away after years on carnivore. We already addressed the microbiome's short-term adaptations, but long-term carnivore living brings even more fascinating changes. Instead of becoming fragile, the microbiome becomes resilient and efficient. It transitions into a low-residue ecosystem where bacterial species that thrive on amino acids, mucin, and internal substrates dominate. These species are not the same ones celebrated in plant-based digestive studies, but they are highly effective for maintaining gut integrity in a low-fiber environment. The colon becomes calmer, less inflamed, and more predictable, and the mucus layer stabilizes because the constant irritation from fiber and plant toxins has been eliminated. People assume that fewer species means a weaker system, but the truth is that a balanced and specialized microbiome is often more stable than a highly diverse microbiome flooded with bacteria competing for fermentable plant material. The body adapts to the fuel it's given, and over years, the carnivore gut becomes a well-regulated, low-inflammation environment that supports immune strength and digestive comfort. This final stretch of controversy also brings up questions about long-term sustainability and whether a person can truly thrive on meat alone. And when you look across cultures, ancient diets, and modern tribes, the evidence repeatedly points to the same conclusion: humans have always thrived on animal-based diets when animals were abundant. Our ancestors grew stronger, smarter, and more resilient during periods where meat dominated their food intake. The nutrients in meat fuel brain expansion, reproductive success, and physical endurance. Tribes today that rely heavily on animal food show robust health markers, strong metabolic function, and minimal chronic disease. The belief that humans need plants is a modern invention, not an ancestral truth. When people embrace a carnivore diet long term, what they often experience is increased mental clarity, stable mood, improved metabolic flexibility, consistent digestion, and a sense of vitality they never achieved on mixed diets. And this leads to the final controversial question, the one that often sits silently in the minds of those considering carnivore. If the body feels better, the gut functions better, inflammation drops, energy rises, and blood markers stabilize, then why does this diet still make people uncomfortable? The reason is psychological, not biological. People fear going against cultural norms. They fear judgment, misunderstanding, and the thought of abandoning beliefs they held for years. But the human body does not care about cultural nutrition trends. It responds to biology, evolution, and nutrient density. The carnivore diet simply aligns the body with the food it was built for. When you understand that, the fear fades, and what remains is clarity about how the digestive system truly works and why so many of the controversial questions surrounding this lifestyle are rooted more in misinformation than in reality.